Hi, Math 1020 students. I have some examples here out of sections 2.5 through 2.8, and I wanted to make a video for you for extra practice. I'll be using Doceri, a program on the iPad, and I will say in advance that as I work through these problems, you're going to hear the sound of the Apple Pencil hitting the iPad. I know it may be a bit of a distraction, but there's nothing I can do about it. So here we've got the prompt: determine the equation through the points in slope-intercept form. I've given you two ordered pairs, and we're going to use point-slope form first. Now remember, the very first thing we need to do is find the slope. So if I want to find the slope, I'll take y2 minus y1 over x2 minus x1. So in this case, 3 minus 1 over negative 2 minus 2. And that cleans up to 2 over negative 4, or negative 1/2. So our slope is negative 1/2. Now, if I'm using point-slope formula, recall that I can put in either ordered pair. It makes no difference. I'll use this one so that I can work with positive 2 and positive 1. And so y minus 1 is equal to negative 1/2 times the quantity x minus 2. We'll clean that up. Y minus 1 is equal to negative 1/2. And when we distribute our negative 1/2 times x, we get negative 1/2 x. Negative 1/2 times negative 2, of course, is positive 1. I'll add 1 to both sides, and our equation is y is equal to negative 1/2 x plus 2. Now, I want to show you an alternate way to come to the same result. So I know that the slope is negative 1/2, and I'll use that negative 1/2, and I also know an ordered pair 2, 1. If I'm trying to find slope-intercept form, I can substitute, instead of into point-slope, I can also substitute into y equals mx plus b. So watch what happens. I'll put 1 in for y. I'll put negative 1/2 in for m. That's my slope that I've already determined. I'll put 2 in for x, and I'm going to solve for b. So plus b, that's my unknown. Now, negative 1/2 times 2 is negative 1, and so I can clean this up to say 1 is equal to negative 1 plus b. Add 1 to both sides, and we find that b is 2. Put 2 into the formula. We already knew the slope was negative 1/2. Put 2 in for b, and I get the same result. Y is equal to negative 1/2 x plus 2. So same equation, alternate way to do this. I'll show you another example. So this time, for the sake of time, I'm not going to use point-slope. I'm just going to do the alternate. So I'll cross out point-slope. I was going to, but I don't want this video to get too long. So the alternate way, again, is you're given a point. You're given a slope. Now, in the previous example, we had to solve for the slope, but it's no different. You've got a slope, you've got a point now. And I'll say y is equal to mx plus b. So I'll substitute for what I know. Well, I know y, negative 3. I know m, negative 3/5. And I know x, positive 4. I can solve for b and put b into the equation. So y, negative 3, is equal to m. In this case, again, m is negative 3 over 5, that was given, times x, 4, plus b. So as we've talked about in class, 4 is 4 over 1. We multiply fractions. We get negative 3 is equal to negative 12 over 5 plus b in this case. If I want to solve for b, I must add 12 over 5. So b is equal to negative 3 plus 12 over 5. Now I'm lacking a common denominator. This is negative 3 over 1, so I can't add these together until after I've multiplied this by 5 over 5. So when I multiply negative 3 by 5 over 5, I get negative 15 over 5 plus 12 over 5. Again, we're solving for b, so negative 15 over 5 plus 12 over 5 is what? Negative 3 over 5. So b is negative 3 over 5. m, our slope, was actually given to be negative 3 over 5 as well. Put it together and we've got our formula. Y is equal to m, that's negative 3 over 5, x plus b, negative 3 over 5. And there is your point slope form, slope-intercept form of the line. If you had gone through the same process here, well, we did actually, so we had an ordered pair and a slope. The start would have been, remember, y plus 3 is equal to m negative 3/5 times the quantity x minus 4. That's y minus y1 is equal to m times the quantity x minus x1. Work through the problem. Maybe try it on your own, and you will get the same result. On to the next slide. Convert to slope-intercept form, and then tell the slope of any line parallel and perpendicular to the line. So we've got 2x plus 3y is equal to 5. I want to put this in y equals mx plus b form. Step 1, of course, we'll subtract 2x. So 3y is equal to 5 minus 2x. Now we've got to divide everything by 3. 3 over 3 is 1. Remember that when you divide a binomial, 2 terms, by a monomial, 1 term, you can split this. And so we get 5/3 minus 2/3 x. So y is equal to 5/3 minus 2/3 x. There's your slope-intercept form. The question is, what's the slope of a line parallel? So any parallel line will have a slope of negative 2/3. If it's parallel, then m will be negative 2/3. What's the slope of a line perpendicular? If it's perpendicular, then m will be the opposite reciprocal, so positive 3/2. On to the next problem. 3x minus 7y is equal to 7. Again, we want slope-intercept, so I'll subtract 3x. Negative 7y is equal to 7 minus 3x. I'll divide everything by negative 7, and we get y is equal to negative 7 over 7 minus 3x over negative 7. Negative 7 over 7 is negative 1. That's your y-intercept. A negative divided by a negative results in a positive, so plus 3 over 7x. Y is equal to negative 1 plus 3 over 7x is your slope-intercept form. Now, if the line is parallel, then m would be the same, 3 over 7. If the line was perpendicular, then m would be the opposite reciprocal, so negative 7/3. Notice, just like in class, we're working with exact values. We're not rounding anything. If I asked, for example, so if I asked a question like, what would be the equation of a line which is perpendicular and goes through some ordered pair like, I don't know, 5, 7? Think to yourself about how you would answer that question. We've done these before. We know the slope. Okay, so we know the slope. We know an ordered pair. We have everything we need to determine that formula, that function. And so if you go back to the previous slide, the material that we talked about in the previous slide, and think about that for a moment, this applies exactly to that. Slope, point, you can use either point slope form, y minus y1 equals m times the quantity x minus x1, or as I talked about in the previous slide, you can substitute m, and you can substitute x, and you can substitute y in order to solve for b. Next, direct proportionality. So r is directly proportional to L. If r is 1.2 when L is 250, then what is r when L is 150? And what is L when r is 1.9? So I'm posing a couple of different questions here. Recall, if r is directly proportional to L, then r is equal to m times L. Remember that the y-intercept will always be 0 if they are directly proportional. So we're given that r is 1.2 when L is 250, and so 1.2 is equal to m times 250. I'll divide both sides by 250. Divide both sides by 250, and we find that m is exactly 1.2 over 250. Now I'm going to, off to the side, I'll punch that into my calculator. So 1.2 divided by 250, I get 0.0048. And that's exactly, nothing's been rounded. So m is 0.0048. And so our model, in this case, would be r is equal to 0.0048 times L. There's your model. Next question is, what is r when L is 150? Well, we know that r is equal to 0.0048 times whatever L is. L is given to be 150, and so r is 0.0048 times 150. So in my calculator, I'll carry that answer over, multiply 0.008 times 150, and I'm getting 0.72. And so the answer to that first prompt is r is 0.72, or 72/100ths. The next question, what is L when r is 1.9? Well, in this case, we would substitute into our formula, we'd substitute 1.9 for r. So 1.9 is equal to 0.0048 times L. In this case, if I want to solve for L, I've got to divide by 0.0048. Divide both sides by 0.0048. And so L is 1.9 divided by 0.0048. And I'm getting 395.83 repeating. Now, remember, you have a tool in your graphing calculator where you can convert that to a exact fraction. And so if I convert that to an exact fraction, 395, again, L is 395, I should say 0.83 repeating. 395.83 repeating is 2,375 over 6. Now, if you know, as you get more comfortable working with these decimals, this repeating decimal here, 0.83 repeating, is actually 5 over 6. And so another way to write this would be 395 and 5/6. So L is 395 and 5/6. All right, last slide. I just wanted to mention that you do need to be able to apply these concepts to real-world examples like the ones that we've worked on in the homework, like the ones that you've seen in lecture, and like the ones that you have seen on your problem sets. I hope you have a great day.